So in yesterday's class we have implemented a linear regression, and today we will finish linear regression. So I am providing you the notes. So we'll just go through these notes what I have given here. So simple linear regression is a statistical method for obtaining a formula to predict values of one variable from another. Okay, so here we are predicting the value of y from x. Linear regression assumes that the relationship between two variables can be modeled by a straight line. Okay, so this is our assumption. Okay, so we assume that the relationship between these two variables can be modeled by a straight line, and we are familiar with the straight line equation. So generally we represent line in the form of y equals to mx plus c, but here in statistics we generally represent it with y equals to beta 0 plus beta 1 x. We give them the following names. So x is the independent variable or the predictor, and y, because as we are determining the value of y from x, so it will be a dependent variable or a response variable. Then it is convention when plotting data to put dependent on y-axis. Okay, so along the y-axis we will have a dependent variable, and along the x-axis we will have the independent variable, that is x variable. So this straight line is our regression line, true regression line, represented by this equation y equals to beta 0 plus beta 1 x, and these are the actual data samples or sample points. As you can see, this epsilon 1 is the error for this first data point, okay, x1. So our regression line will predict this value. Okay, so let me zoom here. Okay, so if you go upwards and if you find the intersection on this line, that will be a predicted value. Okay, but actual value is this one, right? The difference is the error, that is known as sample error. Okay, so for first sample it is indicated by epsilon 1. Okay, similarly for second sample it is epsilon 2. Okay, so you can find the difference between actual and predicted values and you will get the errors. Then this beta 0, okay, so if you continue this line, it will intersect with the y-axis. That intercept, y-axis intercept, is the beta 0 value. Okay, and the slope of this line is denoted by beta 1. Are the constants, they are the constant for this data distribution, and are the parameters that need to be estimated from the data. Okay, so this linear regression comes under supervised learning, right? Okay, so we have to learn these values beta 1, beta 0 and beta 1 from the data. Okay, that need to be estimated from the data. Then, so we have a formula for calculating beta 1. The least square estimate of the slope coefficient beta 1 of the true regression line is given by this formula. Okay, least square estimate. Okay, so here you can find out the error. Okay, you take a square of that, and we want to minimize that error. That's why that estimate is known as least square estimate. So if you know beta 1, okay, then we can calculate beta 0. Okay, now we have done one, we observed one thing. This regression line will pass through x bar comma y bar, right? That is the center of this distribution. So the summation of yi is the y bar. Okay, I have taken 1 by n common. Okay, so summation of yi, summation of xi. Okay, and it is just a simplification of this formula. Okay, we are interested in beta 0, so y minus beta 1 x would be the value of beta 0. Okay, and I have taken 1 by n common. Okay, so which is simplified to the right, y bar minus beta 1 cap and x bar. Okay, so this is regarding simple regression. Okay, so here we have only one independent variable and one dependent variable. In case of a multiple linear regression, okay, so in yesterday's lab we have seen we can predict the house price based on multiple features. For example, square feet living area or number of bedrooms or square feet lot area, right? So if you use multiple features, more than one feature, then it will be a multiple linear regression. And again, it is a linear only. Okay, that's why it will be a line. Okay, line equation only. There is no polynomial here. Okay, x1, x2 are the variables only. Okay, so this is the equation of multilinear regression. Okay, so please take a screenshot of this and you have to write it in your notebook. Okay, now you can take a screenshot of this simple linear regression. Take a second screenshot. Same theory you can write in our lab practical. Okay, lab theory part. Okay, finally about multiple linear regression. Okay, now next thing I want to show you one question from Mumbai University paper. So see this question number 2. The following data table shows midterm and final exam grades obtained for student in database scores. Okay, so we have midterm exam scores and final exam score. Use the method of least square using regression to predict the final exam grade of a student who received 86 on the midterm exam. Okay, so we have to find the regression line equation. From using that linear equation, we have to predict the value of y for when x equals to 86. Okay, so you have to decide which one is the dependent variable and which one is the independent variable. Okay, so x is the independent variable and y is the dependent variable. Okay, so now the data samples are given, so we'll try to learn the regression line equation. Did you understand the question? It is asked for 10 marks. Okay, so we will require around 10 to 15 minutes to solve this problem. Okay, so let us solve this problem. Okay, so I have written a problem here. So we know the equation of beta 1. It is summation of x minus x bar, y minus y bar. Okay, this is I will go from 1 to n. Okay, so these are the given samples. Divide by x I minus x square. Okay, summation I equals to 1 to n. Okay, so we have learned this equation. See, the beta 1 equals to this values. Okay, so we have to calculate this. First we will be calculating x bar. Okay, so take a summation of this, divide by how many samples are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now the summation will come out to be 866 divided by 12. Okay, so the final answer is 72.167. Similarly, we need y bar, so we have to calculate a sum divided by 12. The sum will come out to be 888 divided by 12. The result is 74. Okay, and similarly we have equation for beta 0. So which is y bar minus beta 1 x bar. Okay, so we are going to use these two formulas. Okay, now we have to calculate this bracket. Okay, xi minus x bar. So I will calculate xi minus x bar. Okay, so I is varying from 1 to n, so it will vary from 1 to 12. Okay, so calculate this subtraction for all the samples. Okay, so it will be 0.167. I have already solved it, so I will be writing the values 8.833. Okay, and you fill the table like this. Then we have to calculate yi minus y bar. Okay, so few answers are, okay, so 84 minus 74, that is 10. 63 minus 74, that is minus 11. Then 74 minus 77 minus 74, that is 3, and so on. Then you have to take a multiplication of these two brackets. Okay, so let's call this column as A, this is B, C, D. Okay, so we'll do the multiplication of C into D, column C into D. Okay, this is E column, which is nothing but C into D. Okay, so you do the multiplication, so it would be 167 minus, okay, 243 837, then 26 499, and so on. Then finally you have to take a summation of this multiplication. Okay, so summation of entire column, so that is 2047. Summation is 2047. Then we have to take a square of, okay, square of this bracket. Okay, so we have C, so this is C into C, this is my F column, C into C, that is a denominator. Okay, so I will be calculating a square of these values. Okay, so it is 0.02788, and so on. Continue for all the samples, and then take a summation of that. So summation will come out to be 3445.659. Okay, now this value is my numerator, this is the denominator. Okay, so beta 1 will be, okay, so this is 2047 divided by 3445.659. Okay, the final result of beta 1 is 0.59, and I can use this formula. So we know the value of y bar, that is 74 minus beta 1 is 0.59 into x bar is 72.167. the result is 31.42. okay, so we have the value of beta 0 and beta 1. We have learned these values from the given data samples. So final regression line is, okay, y equals to 31.42 plus 0.59x. This is my regression line equation. Okay, any doubt? Okay, simple mathematics is there. Okay, it is asked for 10 marks, that's why calculations are complex. Okay, now I will cross check this answer by implementing a code. Okay, so you first take a screenshot. Okay, so we have to use this library, linear regression, right? Okay, then these are the x values. Okay, so we have total 12 samples. Okay, so I have inserted these values, then these are the actual values. Okay, y, then I have created an object of linear regression, then we have fitted this data. Okay, so we know that it expects a column vector, so I am reshaping that vector, then y. Okay, and I am printing coefficient and intercept. Coefficient is nothing but a slope, so here I am getting 0.58, but we have obtained slope as 0.59, so there is some round off error. And the intercept, they have obtained 32.02 and we have got 31.4. okay, so that's fine. Now we have to predict the value when x equals to 86. Okay, so you put the value of x as 86 here, okay, and get the value of y. Okay, so you can do that calculation. Now I can show you this line. So for that I will be using matplotlib. Okay, so we have x, y. Okay, so all the variables are same. Okay, so I will run this first and then this. So this is my regression line. These are the sample points, and okay, so I can add some elements, graph elements here. So plt dot x label. Okay, so along the y-axis, what we have? Along the x-axis, we have midterm marks, okay, and plt dot y label. This is end same final exam marks. Similarly, I can, okay, so you can add chart elements. Okay, so I can add legend. I can give different colors to the regression line and all. Okay, so did you get this concept? Okay, so please take a screenshot of this code and write this code after the numerical. Okay, take the screenshot of this also. Okay, so we'll stop here. In tomorrow's lecture we'll be starting with decision tree.